All right, let's go ahead and take a look at the questions at the bottom of the page here now. In these questions here, you're using the Pythagorean theorem still, but you also are not given a drawing. So you actually have to go ahead and create the drawing for yourself or analyze the situation to figure out what's going to be happening here. So what it says in number 10, it says a 20-foot ladder is leaning against a wall. If the ladder is 12 feet from the base of the wall, how high above the ground does the ladder touch the wall? All right, so here's my wall. And what it says is the ladder that leans against the wall, 20 feet long. And what it says, even though it's not well drawn, it doesn't matter. All right, it says the ladder is 12 feet from the base to the bottom of the wall. So we know this distance here is 12. And we're supposed to figure out how high above the ground does the ladder touch the wall. So obviously we're finding the third side of the right triangle as this is drawn. It's pretty easy to see once you draw it. We're finding the other leg here. So if I'm finding the leg, I'm going to use a formula, or I'm going to use the formula like how I used it in question number 5. I'm finding either A or B. It doesn't matter which, as long as you pick one. So I'm going to go ahead and call this A. All right, so formula says here that A squared plus my other leg squared, 12 squared, has to equal my hypotenuse squared, or 20 squared. We can simplify that. We've got A squared plus 144 equals 400. And I'm going to go ahead and knock that 144 off both sides because I'm solving this like I'm solving an equation with the opposite side do the opposite rule. So A squared is going to equal 256. I'm going to go ahead and take the square root all the way across here. And that's how I'm going to finish this. When I take the square root of 256, the result here works out to be 16. So A is 16, which means the wall is 16 feet tall, or the ladder touches the wall 16 feet in the air. All right, let's try one more together. Let's look at 13. It says a rectangle is 26 meters long and 18 meters wide. They want to know what the length of the diagonal is of the rectangle to the nearest meter. So if I draw in the rectangle, obviously here's my right angle, so we're looking for the hypotenuse again, clearly. So we're looking for C. So we're going to solve this one like we solved question 1. I've got A and B, doesn't matter which one I call which. If I want 18 to be A, that's great, or if I want 26 to be A, that's great as well. So I've got 18 squared plus 26 squared equals C squared. And from there I'm going to simplify because I've got 18 squared. 18 times 18 is 324. And I've got 26 squared. 26 times 26 is 676. And I'm going to add those two guys up, and I get 1,000. That's equivalent to C squared. Well, again, I don't want to know the hypotenuse squared, though. I just want to find the hypotenuse. So what I have to do now is take the square root. So I'm going to take the square root all the way across here. And when I take the square root of 1,000 here, the result here ends up being 31.62227766016. It's one of those ones that goes on forever. But since they asked me to round the answer to the nearest meter here, we're going to say that C is about 32 meters long. That's what I get when I take the square root of 1,000.